Hey guys, I'm Nightbite. Welcome back to another video. I'll be covering a question on tangents and normals with a focus on integration. This question is from the O-Levels 2020 Paper 2 Question 10. The function f is defined for all values of x and is such that the second derivative of x is equals to 48x squared plus 2e to the power of 2x minus 1. The line x equals 1 over 2 is the normal to the curve y equals fx at the point where y equals 1 over 4. The first part asks us to find an expression of the derivative of fx. To get the first derivative of the function, we will need to integrate the second derivative. Remember to add the integration constant as it is an indefinite integral. The integral is 16x cubed plus e to the power of 2x minus 1 plus c. Now, we cannot stop here as we need to find a constant term as well. We can find this through the question. The line x equals 1 over 2 is the normal to the curve. As the line x equals 1 over 2 is a vertical line, the tangent to the curve is a horizontal line as they are perpendicular, which means the gradient of the line at that point is 0. With this information, we can substitute x equals 1 over 2 and f prime x equals 0 into the first derivative function. After substitution, the constant should be negative 3. The first derivative is f prime x equals 16x cubed plus e to the power of 2x minus 1 minus 3. The next part of the question asks us to find an expression for the function fx. Similar to the previous question, we will need to integrate the first derivative function. Since the equation is largely the same as the second derivative function, we can use the same methods to integrate it. The function should be 4x to the power of 4 plus 1 over 2 multiplied by e to the power of 2x minus 1 minus 3x plus c. Now, we will need to find the integration constant. We can do this by looking at the question again. The normal to the curve intersects the curve, which means the point of intersection is the x-coordinate of 1 over 2 and the y-coordinate of 1 over 4. We can substitute this set of values of x and y into y equals fx, or y equals 4x to the power of 4 plus 1 over 2 multiplied by e to the power of 2x minus 1 minus 3x plus c. After calculating, the constant should be 1. The function fx is fx equals 4x to the power of 4 plus 1 over 2 multiplied by e to the power of 2x minus 1 minus 3x plus 1. Now, the last part of the question asks us to show the equation of the tangent to the curve y equals fx at the point where the curve intersects the y-axis can be written as 2e multiplied by y plus 3x minus 1 equals 2x plus 1. To solve this, we will be expressing this equation in point-slope form, or y minus y1 equals m multiplied by x minus x1. This means we will need to find the coordinates of the y-intercept and the gradient at that point. Firstly, to find the coordinates of the y-intercept, we substitute x equals 0 into y equals fx. After some substitution, we should get the y-coordinate of the y-intercept 1 over 2e plus 1. Next, we substitute x equals 0 into the derivative of fx to get the gradient of the tangent and the y-intercept. This should be 1 over e minus 3. We next substitute the x-coordinate 0, the y-coordinate 1 over 2e plus 1, and the gradient m equals 1 over e minus 3. After substitution and moving some values around, we should get the equation y plus 3x minus 1 equals x over e plus 1 over 2e. We can change the right side of the equation to 1 over 2e multiplied by 2x plus 1. We move the 1 over 2e of the right side of the equation to the left, changing it to 2e. We can finally show the equation of the tangent is 2e multiplied by y plus 3x minus 1 equals 2x plus 1, finishing the question. Now, I am aware this question can be solved using the gradient intercept form, but A-Math tends to favor answering equation of line questions using the point-slope form rather than the gradient intercept form, so using this form is safer for the exam. With that out of the way, this question is finally done. I promise I'll tone down the number of integration questions from this point forwards, instead covering other topics like differentiation and secondary 4, other secondary 3 topics like binomial theorem. I hope you learned something today, and thanks for watching. All the best for your exams. See you!